let's talk about some forms of exponential functions here. First of all, this is unit 11 for us, not unit 7. I borrowed this from something I made for a different class a long time ago. Okay, but it applies to what it is that we're doing right now. All right, here's a couple different forms of exponential equation. This one we're familiar with. We've looked at this, y equals a times b to the x. Sometimes you will see it written as y equals a with a little 0 small and down low, and then instead of the b, it's written as a 1 plus r to the x power. But you can kind of see the correlation between the two. So in these, either a0 or a, whichever one, and this doesn't really have to have the 0 on there, I just want to put it there because you'll see it sometimes, is going to always stand for the initial population. Okay. The b is, we generally use the word base to refer to that. Okay. If we jump down to this bottom one, we've got the whole 1 plus r, which we know is the same thing as b here. It's the thing that we're multiplying by over and over. That's what exponential notation is about. This is referred to as the growth factor. So b can also be the growth factor or the base. 1 plus r could be referred to as the base. But remember, the word factor means part of a multiplication problem. So it's the factor is the whole thing that we're multiplying by over and over again. X in the exponent, that's our oftentimes time, but it can stand for other things as well. Y is the amount of stuff that we have after X units of time, as it very often is that. Now the R is the growth rate as a decimal. So when we talk about the population of a city growing at 4% a year, if we just take the population of the city, let's say we had a city of 20,000 people, and it's growing at 4% per year. If we just multiply by 0.04, which is 4%, we get 800. That's not the population of the city after a year. That's how many more people were in there. Okay, so the growth rate tells us how much it grows, but those people have to then be added to the population, and that creates a growth factor. So if I did 20,000 and I multiplied by 1.04, okay, if I add 1 onto that, like this up here says 1 plus r, then that adds, it figures out how many more people I have and then adds them to the existing population as well. So I want to keep growth rate and growth factor separate in my head. Okay, it says growth. This could also apply to decay if the growth rate happens to be a negative number. I think we may see that eventually here. It doesn't look like growth. I don't see a lot of that example in here, but we will get to that at some point. Okay, so in each of the following exponential equations, identify the requested value, the initial population. So initial population is that number out in front. Okay, so the initial population there is 300. The growth rate. Growth rate is the part that comes after the 1 in that. So we could write that as 13% as the growth rate, or 0.13. The growth factor is the whole thing that we're multiplying by, so that's the 1.015. This wants the growth rate specifically as a percent, so the growth rate is this part in there, and so that is 0.034. If we change that into a percent, that's 3.4%. So circle the things that they were actually looking for there. The base in this case is a 1/2. Okay, if we thought of this in terms of a 1 plus something, so this is what we were talking about before, if 1 plus r was equal to a half, in this case, then subtracting 1 from both sides would say r is -1/2 or -0.5. And so that's a negative growth rate, and this would be exponential decay that was happening in this. Okay. So now we're going to try to piece these things together using the vocabulary to write equations. So the initial population is 5,000. The growth factor is 1.21. So initial population, y equals the 5,000. Growth factor is 1.21. Put that to an x power. Initial population of 200. Growth rate is 0.06, so I have to add that. I need 1 plus 0.06, which is 1.06 to the x power. Growth rate of 1.3%, I need to change that into 0.013. My initial population was 8,500. 1 plus 0.013 is 1.013 to the x. Initial population of 1,000 or 12,341. Growth factor, it's given me the whole growth factor here, so I just copy that down as it is. I can see a 7.5% growth rate there. Growth rate again of 4% as a decimal, that's 0.04. So this is y equals 6,902 times 1.04 to the x. Y equals initial population 6,900, the growth rate. So 1 plus 0.13 is 1.13 to the x. Growth rate 7.5%, that's 0.075. So we've got y equals 40 times 1 plus 0.075, which is 1.075 to the x power. And that's what that one looks like.